Fourth minus 2 to the fourth. We can't do the rule here. I do see a shortcut, though. This is a number. And this is a number. And they're the same number. And you're subtracting. So if you take away the same number from itself, you're just going to get 0. Plain and simple. And then 11 here, here's the algebraic version. If you have an x, you don't know what it is. But you are multiplying the same base, so you can add the exponent. You can add 3, add 2, and that'll give you 5. Alright, so there are your answers right there. Take a look at that. Again, if that didn't make sense, just rewind the video and see if it does, because we're going to move on to our last rule of the day for this Wednesday here, the quotient rule. This is rule number 2. It's very similar to the product rule, just a little bit different. So, this is the quotient rule. And again, like last time, I'm asking myself, what does product mean? Where have I heard that before? Quotient, that's definitely a math word. That really just means the division rule. Quotient means division. So when does this rule apply? Like last time, we can't just use the rule whenever we want. For example, we can't use the rule when we're adding. We can only use it when we're multiplying things of the same base. So here, we're only allowed to use the rule when we are dividing things of the same base. So say we have 3 over 3, and then the top 3 has a, say, 8, and this one has a 6. Since we are dividing and the bases are the same, we can use this rule. So must be dividing and must have the same base. The exponent, the 8 and 6, those are different, but those don't have to be the same. But these have to be the same, the bases. So how this works is it's quite simple, just like the multiplication one. If you have 3 to the 8th over 3 to the 6th, what you're just going to do is subtract the exponents. So subtract those. 2. So you get 3 squared. 3 to the 2. That's it. And you should know that 3 to the 2 is 9. Here's the proof. Again, similar. So 3 to the 8th over 3 to the 6th. That's really going to be 3 multiplied by itself 8 times. This is really going to be 3 multiplied by itself 6 times. And then if you notice, you're going to be able to cancel these out. So there's 1 gone. There's 1 gone. There's another 3 gone. There's another 3 gone. There's another 3 gone. There's another 3 gone. And what you're left with is how many 3s? 2. 2 3s being multiplied. 2 3s being multiplied. And that's why that rule works. Again, not terribly important that you memorize that, but you don't just want to take things for what they are. You want to make sure you can see where it's coming from. Okay, algebraically, likewise, say you have like x to the a power divided by x to the b power. That's going to simplify to x to the a minus b. We're subtracting when we divide. All right. Okay, so there's the notes right there. We're going to do one more practice grouping together, and I'll show you a little bit with the calculator, and then I'll let you guys try the assignment for tonight. And it's much shorter, don't you worry. Okay, so first step, decide if you could use the quotient rule. Sometimes we can't. We have to be divided by the same base. If yes, just simplify. If no, just evaluate. So again, I'll do a couple with you here, and we will take it from there. So, 2 to the 6 over 2 to the 4th. Yeah, we have the same base, so you're going to subtract the exponent. 6 minus 4 is 2, so it's going to be 2 to the 2. You might know that's 4. 2 squared is 4. You don't have to write that, though. If you do, great. If not, no big deal, because it just says simplify. So you don't have to evaluate it out and get one number answer. All right, there's that one. I want to try... I'll do this one with you right here, and then I will let you guys... I'll do this one too. So 2 more. So let's see, 5 squared over 6 minus 1. This definitely can't use the rule. There's only one 5. We are dividing, but there's only one 5, and there's subtraction going on. This is crazy. So we're going to do this normally. So 5 squared is just 5 times 5. You guys agree? Thank you. Thank you. Sound of the internet. Divided by 6 minus 1, which is 5. Hey, you might be able to notice you can cancel stuff out. If not, you should get 25 over 5, and 25 over 5 is simply 5. Cool. All right, last one here. Down here in the corner, we got 10 cubed over 10. Again, it should be written down here on loose paper. I see that we have 10s. So we know we're talking about 10, so that's good. They're both 10 and we're dividing, but we don't know what exponent is on the bottom. Anybody have any guesses what that would be? Because there is an exponent. If you said uno or 1, you'd be right. There's an invisible 1 there, just like in front of an x when you solve an equation. There's an invisible 1. So same idea with exponents. If there's no exponent there, there's a 1. So now this question becomes much more simple. 10 to the 3 over 10 to the 1. That will just be 10 squared, which is 100. But just said simplify. Okay. So I want you guys to try the rest of this on your own. Pause the video and resume when you're ready to see the answers. Okay, this one, you have the same bases, so you should get 3 to the 1, which is really just 3. Again, you didn't have to do that, go that far, but that'll do. 6 squared over 2 squared. These are not like bases, so we can't use the quotient rule. So we got to proceed as normal. 6 squared is just 6 times 2, or excuse me, 6 times itself twice. 2 squared is that, so you'll get 36 over 4. 36 divided by 4 is 9. This one, again, you can't use the rule. So 4 squared times 4 times 4, and then 2 cubed is 2 times 2 times 2. So you get 16 over 8, and that is 2. Again, I just take my numerator, do 4 times 4 is 16, and then I do 2 times 2 times 2 on the bottom to get 8. This one right here, 2 cubed times 2 squared, that's not the quotient rule, that's the product rule. So we have the like bases, and we're going to add the exponents. So we'll get 2 to the 5th. There we go, I snuck that one in on you. Hopefully I didn't get you. X to the 7th divided by x cubed, x to the 3rd power rather, or the same. Same bases, so subtract exponents, get x to the 4th. And then some of these trickier ones down here. This one in particular, the hardest one. Before we subtract, there's actually a product rule in here. So we're actually going to do the product rule. So we're going to get 2 to the 7th all over 2 to the 5th. And now if you have that, you should be you should be good to go. You should get 2 squared at that point. All right. This one, again, you can't use the rule. So you get 3 times 3 over 6 times 6. Maybe you just recognize that, hey, 3 squared is 9 and 6 squared is 36. And if I don't know what that is as a fraction, I'll just leave it. It is 0.25, but both answers work there. And this one, yep, you have the same bases. They're 5, so you can subtract the exponents. You should get 5 squared. So hopefully that went well. Definitely a little tricky. These rules are tough. Once you get the hang of it, you should be good. The key idea, like I said, for the product rules, you gotta know when it applies and how it works. I do want to take a second. Your calculator can be powerful, you know. I'm not going to neglect that. With this question, though, let's see if our calculator would help us, or did we really need the rules? So what I want you to do, if you have your calculator, pull that out. I'll show you where the exponent key is. So here is the scientific calculator that you have, if you have it. It's the button. So say you want to type in 5 to the 18th. You would type in 5, and then the button that looks like a upside down V. It's right beneath the pi symbol. It's like diagonal from the 7. So it's the one that looks like a V, an upside down V. So if you want to do 5 to the 18th, you would do 5, the caret symbol there, and then 18, and press enter. And that should give you a crazy number. For those of you who don't have that calculator, I'll show you right here. If you do 5 to the 18th, you get some crazy excuse me, you get some crazy number. So how would I write that? How would I do that? That's why we need our exponent rules, because sometimes calculators can't handle big numbers, and you can bet that there are some very big numbers out there that exist in the world. For example, how many miles to the sun? That's a very large number, and we need to represent it in different ways. So that's why exponent rules come in handy. So really the best way of telling what the answer was by doing it out, and now 5 squared is much more calculatable. That's just 25. All right, good job with that. That's kind of why we need to know those rules. This is for you guys here. 3 questions for you to see, do I get it? Just 3. If you can get these 3 right, you won the day. You won the day in math class. So read those directions there. Pause the video, give it a shot, and when you're ready to see if you understood it, resume the video. All right, here, number 1. I hope you guys wrote that this is the quotient rule. And I hope you accurately saw that this is 9 to the 1. The next one, I hope you guys saw that this is the product rule. We're multiplying the same number by itself. So we're going to add these exponents. You should get 3 plus 4 plus 7 will give us 2 to the 14th. And right here, I hope you guys notice that even though these exponents are the same, we can't do anything with it. They don't have the same base. So you should just do this out as normal. So 1 times 1 times 1 times 2 times 2 times 2 should give us 1 times 4 times 2, which is just 8. So no rule, and it equals 8. All right, that's all I got for today. Check out the assignment, and please post any questions or comments if you have them. There may be a video posted later up today just to give you guys some general announcements about what's going on in Westmoreland during this process, but stay tuned and ask if you have any questions. All right, thank you. Bye-bye.